Have you ever wondered about the mysteries that lie within our solar system, specifically around the gas giant Jupiter? Step into the mysterious realm of Callisto, one of Jupiter's biggest moons. But there's more to it than just its size. Besides being one of the largest moons, scientists believe its surface holds the title for the oldest planetary surface in the entire solar system. It could be guarding the secrets of the early solar system's formation. Join us as we uncover the fascinating discoveries Callisto might unveil in the future. While you might assume that NASA or ESA leads the exploration of Callisto, there's a third nation vying to reach this intriguing moon. But before we delve into that, let's acquaint ourselves with the fourth moon of Jupiter. Callisto, also known as Jupiter 4, was first discovered back in the 17th century, precisely in 1610 by the renowned Italian scientist-astronomer Galileo Galilei. The celestial body stands as the second largest moon of Jupiter, after Ganymede, and is the third largest moon in the solar system, trailing behind Ganymede and Saturn's Titan. Its diameter of 2,995 miles makes it roughly a third larger than Earth's moon, and it orbits Jupiter at an average distance of 1,170,000 miles, about 6 times further out than our moon orbits Earth. It is the outermost of the 4 large Galilean moons of Jupiter discovered in 1610 with one of the first telescopes, visible from Earth with common binoculars. Since its discovery, several spacecraft have had the opportunity to visit Callisto. First in line were the Pioneer 10 and 11, launched in the early 70s by NASA. These trailblazers flew by Jupiter and its moons, capturing the first close-up images of Callisto's heavily cratered surface. Following the Pioneers, the Voyager 1 and 2 missions in the late 70s provided a more detailed view. However, these missions achieved what is known as flybys, indicating that the spacecraft only had a single opportunity to capture images and collect data. They did not enter orbit around Callisto. These missions offered humanity unprecedented insights into Callisto's unique features. The surface, covered in impact craters, does not display the typical signs of subsurface processes like plate tectonics or volcanism, suggesting an evolution predominantly shaped by celestial impacts. The Galileo orbiter, launched in the late 90s, orbited Jupiter for nearly 8 years, confirming the existence of Callisto's thin atmosphere and providing compelling evidence for a subsurface ocean. This discovery ignited scientific interest in Callisto as a potential host for extraterrestrial life. These missions have not only added to our knowledge but deepened the mystery surrounding this distant moon. Now you might be wondering, why have only 5 spacecraft ever explored this captivating celestial body? Sending probes to Jupiter's moons and achieving orbit around them is a formidable task, primarily due to the substantial distance involved. Jupiter, being a gas giant, is situated far from Earth, leading to prolonged communication delays. This distance complicates real-time control of spacecraft, making it challenging to address unexpected issues promptly. Additionally, the massive gravitational forces exerted by Jupiter add complexity to navigation. Navigating through the intricate gravitational field requires precise calculations and adjustments to ensure that the probe reaches its intended moon accurately. The gravitational pull can also influence the probe's trajectory and compromise orbit stability, requiring meticulous calculations, planning, and execution for successful missions. So, what have we learned about the geology of this enigmatic moon? Let's embark on a journey to decipher the geological secrets of Callisto. This moon, the outermost of Jupiter's 4 Galilean satellites, presents a surface so heavily cratered that it's believed to be the most battered in the entire solar system. Each crater tells a story of celestial collisions over billions of years, painting a timeline of our cosmic neighborhood's tumultuous past. Beneath this primordial landscape lies a hint of something extraordinary. Callisto, despite its seemingly inactive surface, may harbor a 6-mile-thick subsurface ocean. The Galileo spacecraft revealed that this ocean, potentially containing liquid water at depths greater than 90 miles, adds a layer of complexity to the moon's composition. Would it surprise you to learn that this seemingly desolate rocky moon possesses an atmosphere? Adding to the intrigue, Callisto is enshrouded in an extremely thin atmosphere composed of carbon dioxide and probably molecular oxygen, as well as a rather intense ionosphere. Callisto's rotation is tidally locked to its orbit around Jupiter, always facing the same direction, making Jupiter appear to hang directly overhead over its near side. This unique characteristic, combined with the presence of a subsurface ocean, positions Callisto as a celestial body of great interest and complexity. Callisto's unique geological features continue to intrigue scientists and spark curiosity about what lies beneath its icy surface. This moon is not just a silent witness to the solar system's history, but a mystery to unravel, a new chapter in our quest to understand the universe. Unlike its siblings, Callisto possesses a weak magnetic field induced by Jupiter's powerful magnetosphere. Due to its relatively low radiation levels compared to other Galilean moons, Callisto has often been viewed as a potential primary base for future crewed missions focused on studying the Jovian system. With so much still to learn, what does the future hold for the exploration of Callisto? As we peer into the future, the prospect of further exploration of Callisto is rife with possibilities. Both NASA and the European Space Agency have expressed keen interest in Callisto, but here is a third competitor we didn't see coming: China. The upcoming Tianwen-4 mission from China, set to explore Jupiter, presents the Jupiter Callisto Orbiter, JCO. The mission involves a spacecraft conducting flybys of Jupiter's irregular satellites before entering a polar orbit around Callisto. This mission profile includes the possibility of a Callisto lander, offering unprecedented insights into the moon's formation and evolution. The JCO mission's rationalization for Callisto as the primary target includes its accessibility with less fuel required for landing, and its location outside Jupiter's intense radiation field. Additionally, the JCO profile includes a secondary spacecraft for an independent flyby of Uranus in the late 2040s, providing an extended exploration beyond the Jovian system. A potential trajectory and timeline for an Earth-Jupiter mission were outlined during the 2020 General Assembly meetings of the EGU. In this proposed scenario, the Tianwen-4 probe would be launched in September 2029, followed by a Venus flyby 6 months later in April 2030. Subsequently, the probe would encounter Earth twice, with the first encounter in February 2031 and the second in May 2033. Prior to reaching Jupiter, the sub-probe would detach from the main probe and proceed towards Uranus, with a scheduled flyby in March 2045. One of the most tantalizing aspects of Callisto is its distance from Jupiter's harmful radiation. This, coupled with its stable surface and subsurface ocean, makes it a compelling candidate for human exploration and even colonization, as we mentioned before. Callisto's subsurface ocean could provide a source of water, and its distance from Jupiter's radiation belts makes it less hostile to human life than many other locations in the solar system. It's a prospect that prompts us to dream big and contemplate the vast potential of space exploration. While the path to such a future is fraught with challenges, the potential rewards are immense. The exploration of Callisto could yield groundbreaking scientific discoveries and a new frontier for human settlement. As we continue to reach for the stars, Callisto stands as a testament to the unending quest for knowledge and discovery in our vast universe. We hope you enjoyed this episode, and want to thank you for watching. Please subscribe to Orbital Prime and click the like button along with the bell to be notified when we release new episodes.